On this quick guide video, we will show how to configure and use the selective optical power meter function to validate optical signal levels for 1G and 10G PON links using a VXPX90, the PON service installation meter. If you are interested, at the end of this video we will briefly discuss the importance of selective optical power meters in coexistent PON networks and compare it to a regular broadband OPM. This simplified network diagram shows that the PX90 OPM can be used anywhere on the PON optical distribution network. It can be used at the OLT site to measure the XGS PON output, the GPON output, or connected after the coexistence element to measure both. It can also be used towards the ONT site, at the street cabinet, the customer's drop, or inside the home, before installing the ONT. Just make sure to set the correct site and thresholds to validate the required signal levels. Even if your company is currently deploying 1G PON, you may still need to consider a selective OPM, since it is very likely that 10G PON would be seamlessly deployed on top of it in the near future. Now, let's start by configuring the PX90 test set to match the PON link or port under test. Press the power button to turn the test set on. First, if you share the test set with other field technicians, let's make sure it is using your personal profile. Tap on the owner button, and make sure the correct user profile information is loaded. In this case, both the company and user information will be added to the test reports header. Then, go back to the main menu. Tap on the PON OPM button to access the optical power meter application. On this example, the meter was configured to simultaneously measure GPON signal level on the top, and XGS PON on the bottom. The low message indicates that no signals have been connected to the test set yet. Besides wavelength and power level, the result fields contain extra information used for the pass-fail evaluation, such as the PON transmitter class, site or location where the test is being performed, and the acceptable optical power level range for that port. Swipe up from the bottom to reveal the test applications menu. Tap on the config button. First, select if you are going to measure 1490 nanometer GPON only, 1577 nanometer XGS PON only, or both 1490 and 1577 coexisting PON signals. Coexistence means that there are two or more types of PON, as well as some other signals, present on the fiber drop under test. It is recommended to enable the thresholds, to let the test set perform pass or fail evaluations for the optical signal levels being measured. If the test set is configured to simultaneously measure GPON and XGS PON, two sets of thresholds are available. The test set comes pre-programmed with a set of standard thresholds. The acceptable optical power level ranges depend on the PON types, site or location where the test is being performed, and the OLT's transmitter class. The thresholds are used to determine if the signal under test passes or fails the requirements set for the current test point. Users can also customize their own pass-fail thresholds. Select the GPON first. These minimum and maximum thresholds are used to determine if the signals under test pass or fail the validation. If you are at the fiber distribution cabinet or at the subscriber's site, select ONT. The applicable 1G PON classes and standard acceptable optical signal levels will be displayed. Tap to select the class that applies to the link currently under test. If you are at, or near the OLT site, select OLT. The applicable 1G PON classes and standard threshold levels will be displayed. Select the class that applies to the port or link under test. To customize the thresholds, you may drag the sliders to adjust their values, or tap on the blue boxes to enter the desired values directly. Tap on Back to return to the main configuration page. Now, select the XGS PON threshold field to configure. Select the applicable 10G PON class for the link or port under test. Tap on Back twice to return to the optical power measurements page. That is all the configuration required. Clean the fiber optics patch cord connectors, the optical port on the fiber cabinet panel, and the test set's SCAPC test port. And let's start making optical power measurements by connecting the PON optical signals to the test port. The test set should immediately display the optical power level readings. It's that simple. Based on the thresholds, passing levels are highlighted in green, while failing values are highlighted in red. Once you are satisfied with the readings, swipe up from the bottom to reveal the test application menu.
Tap on the Save button to store the current results. You should customize the file name with a descriptive name and add any extra job-related information. Then tap on OK.
Swipe down from the top of the screen to reveal the main menu.
And select Files. The previously saved OPM demo file is on the top of the File Manager list. Tap on it to view the test results.
You can swipe up and down to scroll over the full test report content.
Tap on Back to return to the Files list page.
Swipe to the left on top of a desired file to rename, upload, send to USB memory stick, or delete. When finished, go back to the main menu. Tap on the OPM button to go back to the optical power meter application and continue testing. Now, for those interested on why selective PON power meters are required for measurements in modern PON networks, here is a quick and simple explanation. Early adopters of PON access technology started with 1 gigabit PON. That is, a single optical carrier at 1490 nanometers. Late adopters have the choice of starting with 10 gigabit PON. Today, in 2024, modern OLTs support both 1G PON and 10G PON, so it is not uncommon to find both technologies coexisting on the same fiber, since they use different wavelengths. If you are 100% sure that the optical distribution network under test only carries one PON signal, you may be able to use a regular broadband OPM. However, it must have a calibrated selection for 1490 nanometers in the case of GPON, or 1577 nanometers for XGS-PON.
If your OPM is not calibrated for those wavelengths, the optical power level measurement will not be accurate. This simplified functional diagram represents a general-purpose optical power meter with a single broadband photodetector. Regular broadband OPMs are meant to measure a single wavelength signal. In this case, all the light coming from the fiber can be measured correctly if the OPM was calibrated for it. If there are more than one PON signal, a regular OPM will measure the combined optical power hitting the photodetector. That would be the wrong level measurement. In a few cases, there may also be a 1550 nanometer signal carrying legacy TV or video content. Since modern OLTs can support GPON and XGS-PON, there is a good chance that the service provider may turn a secondary wavelength for a test or field trial, and you may not be aware of it. That is the reason why selective OPMs are recommended for PON network environments.
Selective power meters have independent photodetectors, and use the right filters to isolate and measure individual PON signals, as well as blocking any other optical signals that may coexist in the optical distribution network. We hope you found this quick how-to guide video helpful. Feel free to contact us if you have any questions or need more information. Thank you for your attention and interest in VX Test and Measurement Solutions. Please consider subscribing to our LinkedIn and YouTube channels to get notified about new features, quick guide videos, technology, and training contents.